Hey y'all, here we are at lesson 9.2. We're going to talk a little bit in more detail about acids and bases. Basically, you can define acids and bases in three different ways. Chemically, you can define acids and bases in three different ways. So we're just going to kind of go over those three things for this next section. The first way acids can be defined, discovered or developed or defined, I guess, by a scientist named Arrhenius way back when. And so it's obviously this method is named after him. But Arrhenius acids are, excuse me, substances that produce hydrogen ions. Remember we talked about that in the last section. Also called hydronium ions. Hydrogen ions in solution. So those are H plus, right? Hydrogens with one less electron, so they have a positive charge. And Arrhenius bases are substances that produce hydroxide ions in solution. That is the OH minus. And when you have an Arrhenius acid and base reacting together, they produce a salt. Sodium chloride, potassium chloride, barium chloride, sodium bromide, potassium bromide. Anyway, there are many different salts, and water. And you can see here where the water comes from, right? Here's an H and an OH. You put those together, you have H2O, right? So that's the water. When these acids are mixed together. So for an example, if we have hydrochloric acid and sodium hydroxide, this is a real basic one, but I'm going to write this equation up here at the top. But when you add those two things together, HCl plus NaOH, this is a double displacement reaction. Remember where the positive and the negatives switch. So the hydrogen will come and combine with the OH to make H2O. And then the sodium and the chlorine will combine to make NaCl, table salt. Right? So all of these Arrhenius acids and bases work together like this. They make this specific double displacement reaction where you have water and some type of salt. The next type of acids and bases, the next definition, are called Lewis acids and bases. Basically, these types of acids and bases, we'll define them here, but Lewis acids are substances that accept a pair of electrons from another substance. So they take a pair of electrons, and to be the opposite of that, Lewis bases are substances that donate a pair of electrons to another substance. So you have the acid, like in this example, barium fluoride, and the base, ammonia. And what happens here is this base will donate a pair of electrons to the acid, and donated electrons equals a bond is formed, right? So a bond is formed, and you end up with this compound right here. Because of those electrons donated by the base, accepted by the acid, causes them to combine together. So this is a synthesis reaction. Remember we talked about those. And remember I said this was a double displacement. All right, the third type of acids and bases, or the third definition, is these Bronsted-Lowry. And just to kind of, these are somewhat like the Lewis acids, just the opposite, right? So Lewis acids accept electrons Bronsted-Lowry acids donate protons to another substance. And Bronsted-Lowry bases are substances that accept protons from another substance. So it's just kind of a different way to talk about this, although here we're talking about the electrons, and with the Bronsted-Lowry, we're talking about the protons. So it kind of makes them the opposites of each other. We need to talk for a minute about conjugate acids and bases, which goes along with this Bronsted-Lowry theory here, or definition, I guess is a better way to say that. Like it says, using the Bronsted-Lowry acids and bases definition, donating and accepting protons. An acid is any species, we just said, donates a proton, an H+, and a base is a species that accepts that proton. So the product that has accepted the electron, remember up here with this, it was accepting electrons, is called the conjugate acid. So donating proton, accepting an electron, that's a conjugate acid. It's kind of like a yin and yang type of thing, right? And then the substance that does not have the accepted electron is the conjugate base. Conjugate base. So if we look at example equations that deal with this, here we have acetic acid. So it's my acid. And water. This time my water happens to be a base. As you look over here, water sometimes can be an acid or a base because it's neutral. It will work either way. So here I have acetic acid and water. We're mixing those two things together, and we get, this is our hydronium ion. It is called the conjugate acid. And this is the conjugate base. All right. Conjugate acid, conjugate base. Same here, right? This time we have ammonia, it's a base. Water is acting as my acid, because remember, it can be either one. So this becomes the conjugate acid. I didn't leave myself much room for that. And this is the conjugate base. All right. So take a minute, try this one, and we'll come back and see what you get. All right, did I give you enough time? If not, press pause and then come back. Hopefully you remember from the other lesson that HF, hydrofluoric acid, is an acid. This time that means the water is working as a base. And if you look at this and use this up here as your example, you see this hydronium, H3O plus, is the conjugate acid, I'm going to abbreviate, and this with the minus is the conjugate base. So hopefully you're able to figure that out and get those labeled. One last thing from this lesson is the back, or the next note page we're not going to worry about. So you can skip that one, and we will come back in the next lesson with the next page of notes.